Good morning, students. Welcome back to Digital Signal Processing class. In today's class, we are going to talk about the FFT. The today topic of discussion is FFT. What is FFT stands for? It stands for Fast Fourier Transform. So basically, what is the FFT is all about? FFT is nothing but we'll be taking DFT concept. In the DFT concept, what we have learned, we have discussed the N domain signal can be converted into K domain signal and the vice versa. That is inverse DFT. In that, what we have discussed? We have discussed K domain signal can be converted into N domain signal by taking the discrete sequence. In this fast Fourier transform, what we are going to see? We are going to see the performance of this DFT and IDFT and how fastly, how efficiently you can able to solve the complex kind of problem into very simpler form. So our today's criteria of discussion is we are not able to solve that particular thing. As you have discussed in DFT what you have done, you have taken a sequence by using the formula of x of n is equals to x of k. These kind of formulas we have seen. By doing that one, we have able to find out the solution of it. But whereas in fast Fourier transform, we are using the graph. So what is that graph is all about? It's about 2 point, 4 point and 8 point. By taking the 2 point radix 2 point DFT, by taking radix 2 point FFT, by taking the 4 point radix 2, then by taking the radix 8, like this we are going to take different format of your FFT algorithm. By taking those things, we are able to find out the fast Fourier transform. So basically, what is the FFT is all about? So when we are saying it is FFT, that means whatever the things we are solving, it needs to be efficiently handled, very efficiently, faster way. How do we do it? In order to do these things, we'll see one questions what we have seen. We have seen that if you do have x of n, that is you are taking your signal. What type of signal you're taking? You're taking n domain signal, you want to convert into f domain signal, you're taking FFT. So before doing this FFT, we are converting what? DFT. What is the DFT formula? So DFT of your input sequence x of n is equals to x of k is equals to summation. We'll take the limits of it. What is the limit? K is equals to 0 to n minus 1, n is equals to 0 to n minus 1, x of n e power minus j 2 pi k n by n. Right? What is this is called? This is called as Twiddle Factor. By taking this Twiddle Factor, what we are going to see? By taking this Twiddle Factor, we are going to change this Twiddle Factor because in FFT we don't want to apply the complex type of problems. In this, we are going to solve by using the graphs. So first thing we should know, how do we correlate? So x of k is equals to n is equals to 0 to n minus 1, x of n e power minus j 2 pi k n by n. This we know it. So after knowing these things, what we can do it? We want to convert this particular thing into a format of your logics. So how do we do that logics? We will see by seeing the graphs of it. So students, we are going to take this sequence. What we are writing? This is nothing but your Twiddle Factor. So this Twiddle Factor, what we are going to write? We are going to write by taking this DFT of x of n. So if we are writing x of k is equals to summation, this as it is, n is equals to 0 to n minus 1, x of n. Then this I am writing some weighting sequence w n of nk. So what is this indicates? This is nothing but like a weighting sequence in which you are going to find out the value of that particular frequency. So how do we do it? If you had any complex number, suppose if I'm using impedance function z is equals to r plus jx. This is my real term, this is my imaginary term. In the same way, I want to expand this one. How do I do it? Same, I'll write summation n is equals to 0 to n minus 1. This real part of x of n plus j into this imaginary part of x of n. This is my first sequence I have written. Similarly, I can write for the second one. This one I can write real of w n of nk plus j of imaginary of w n of nk. Like this I can write. This sequence I am writing in this way. So the first one I have kept as it is. For the second one I have written like this. Now what I need to do? I need to just multiply this first real part of this with real part, what I'll get? I'll get summation n is equals to n minus 1 real of x of n into real of wn of nk plus I'll multiply this with the second one, what I'll get? J I'll take common, I'll write real of x of n, this imaginary of wn of nk I have taken. Like this I can multiply with this one, with this first one. J anyhow constant, so I'm keeping this as it is. I can write real of wn of nk into imaginary of x of n. Then if I multiply this with this, what I'll get? J into j, j square, that is minus. So that minus I can write. So minus of what I'll get? Imaginary of x of n into imaginary of wn of nk. That means this and this, my is real part and this is my imaginary part. A whole is having the summation. So what actually we are doing in this, we just want to find out your Twiddle factor sequence. That Twiddle factor sequence, what we are writing? We are writing some weighting sequence wn of nk. Because in order to find your FFT, we need to modify this. This Twiddle factor we need to modify, we'll write it. So after writing this thing, what we'll write? We'll write the first. What is the first criteria to solve this thing? We need to know what is the sequence we are going and what is the meaning of this thing. So what is this thing we are doing? We got, what we got? Summation n is equals to 0 to n minus 1. I have the first one, that is real part of x of n into this real part of omega n of nk minus imaginary of x of n into imaginary of wn of nk plus again j into summation n is equals to 0 to n minus 1. What we got now? We have this thing real of x of n into imaginary of wn of nk plus real of wn of nk into imaginary of x of n. So we separated your real part and this is your imaginary part. These two indicates what? That indicates your weighting sequence of your real and imaginary. That since if you see this one, it's very complex, right? In order to solve these problems, if you want to proceed with DFT, it take lot of calculation, it take lot of simplifications, and the time duration would be increased. So in order to eliminate that kind of criteria, that kind of problem, we are proceeding with our FFT, in which we don't want to solve these all kind of things. We just want to solve by using the graph. From the graph itself, we want to find out the value. So how we'll do it? So first thing, we have to understand two kind of thing when we are proceeding with your FFT. There will be a radix 2 and there will be a points. So first, when we talk about the points, there are 2 points, 4 points and 8 points FFT. So in that, we'll be having two category of it. One is decimation in time. Next is decimation in frequency. There are two types of your FFT. The butterfly diagrams we will be having. The graph what we are designing, that is called butterfly, in which the graph itself resembles the bit reverse order value and the normal order. That we will see now. So students, so we are proceeding with your FFT, in which we have seen just now how do we convert your numbers, that is your longer duration number into the smaller one. That part we have seen. Second part what we are going to see is how the complex kind of questions we are going to modify it into the simpler one, that we can do by using the FFT. So in this, what actually FFT is all about, if you had n square number of computation in your DFT, that can be reduced by converting into n by 2 with a log 2 of n. Number of computation is required. So see, n square means if you keep on substituting the value, it keep on increasing the computation. Whereas if you substitute here, this is just computation formula. How do we convert the number of stages into smaller decimation? So that means decimation in the sense you want to make your bigger issue into very smaller one. So that you can do it by converting your number of computation. What is that computation means? The calculation on the steps. So number of computation that you can reduce into this particular form. So in this, what is actually the addition? How much you can do the addition in FFT? Addition computation and your multiplication. So if you want to add any kind of number, the number of steps is required is n log 2 of n. For addition, we require this number of computation in fast Fourier transform. So whereas to do the multiplication, it's n by 2 log 2 of n. So based upon these addition and multiplication concept, it has become quite easy because log of some value always will be less as compared to the square of it. So in DFT, the steps is very complex to solve the problems, whereas in FFT, we can convert that into this particular format. That is, addition and multiplication can be easily done by using this FFT kind of concepts. In this FFT, what we are saying, FFT is divided into how many types? It is divided into two types. One is decimation in time, DIT FFT. Second, DIF FFT. So what is DIT stands for? It stands for decimation. So decimation in time. So we are converting your frequency into your sequence into time domain, and we are want to find out DIT FFT. Whereas in DIF, what is DIF stands for? Decimation in frequency. So in this, your sequence is being converted into frequency domain, and then you can able to find out the fast Fourier transform. So by converting into decimation in time and decimation in frequency, FFT problems can easily be solved. In this, whatever the numbers, so numbers, whatever the number sequence they gave you, we are segregating. We are segregating into two parts. One is even component, XE of n. Another one we are converting into odd components, XO of n. E of n indicates is what? Even component. O of n indicates what? Odd component. So we are converting into even and odd. Both are separated. If you do have, suppose n is equals to 8 points they gave in the question. So how do we convert that 8 point? That 8 point we convert into two components. One end we do have even. So even means XE of n. Another end we do have odd. What odd means? XO of n. So we convert your numbers into even component separately, then odd component separately. We will try to just segregate this both of them, and we try to find out the fast Fourier transform. So how do we do it? Suppose I am taking first one. If I am having, suppose this is my n is equals to 8 point FFT. If I am doing, this is my first block. So in this, what I am doing? 1 2 3 4 1 2 3 4. So in this, what is the first bit value we do have? XE of 0, XE of 1, XE of 2, XE of 3. What is E indicates? It's even components. If you do have odd, how do we write? XO of 1, 0, XO of 1, XO of 2, XO of 3. That means it's all about odd component. This is about your even component. So what is this even component means? What is the even component value? X of 0 is even number. X of 2, X of 4, then X of 6. So these are what actually? These are even numbers. How do we write this second one? To do the second one, what actually we are converting into? Odd components. So what is the odd components value we do write? We'll write it as X O of 1. Then X already will write over there. X of 1, X of 3, X of 5 and X of 7. So as you can see in this, what we are doing? We are converting your even components and your odd components separately, and then we are finding your n is equals to 8 point FFT. So this is the way, just one step of it. How do we write the normal order sequence and your bit reverse order sequence? That we will see after this one. So that how do we do it? That we will see after drawing its complete diagram. So see students, so we are taking next one, construction of 8 point DFT from 2 4 point DFT. So in this, what actually we are doing? We are taking the graph of it. We are taking 8 point, means whatever the output is there, that should start, that should have 8 values. X of 0, X of 1, X of 2, X of 3, X of 4, X of 5, X of 6 and X of 7. So this is our output. That means it should be 8 point. That 8 point, how do we are converting? We want to get from 4 point DFT. So in order to do these things, what I am doing? I am taking 4 point DFT of first sequence, again 4 point DFT of second sequence. In this what I'm doing, I'm taking first is nothing but like even numbers. So first I'm taking even here, then next I'm taking as odd. So what is the first even? XE of 0, XE of 1, XE of 2, XE of 3. Likewise here I'll take XO of 0, XO of 1, XO of 2, XO of 3. This sequence I'm counting. O indicates it's an odd number, E indicates it's an even number. So what is this? O means X of 0, it's even, then X of 2, then X of 4, then X of 6. So these are my even components. That even components output, if you want to write 1, 2, 3 and 4, that will be start from this fourth one, because we want to write even component, right? X of 4. Then next is X of 5. The next is X of 6. Next is X of 7. So that indicates those are even components. What is the output of this block? X even of 0, X even of 1, X even of 2, X even of 3. So we wrote even component. Likewise, you want to write the second one, second 4-point DFT for odd. So how do we write X E of 0? So X O of 0 is what? Odd component. What is the odd number? X of 1, then X of 3, next X of 5, then X of 7. That indicates it's an odd component. So to write the odd component, what we'll do? 1, 2, 3 and 4. This we will start from combining from 0. So this is first output. This is your second. This is your third. This is your fourth. So this is what is the output of this one. For this block, what is the output here? Odd, right? So X odd of 0, X odd of 1, X odd of 2, X odd of 3. So when we write the fed back, it is called as feedback for it. So how do we write? We'll write weighting sequence. What is weighting sequence? Wn of nk, right? What is n indicates? How many points? 8 point. That means I can write W8 of, what is this first one? It's 0. W8 of 1, W8 of 2, W8 of 3. What is Wn of nk? Wn of nk is weighting sequence, e power minus j 2 pi kn by n, right? This is nothing but your twiddle factor. That twiddle factor, instead of writing this whole exponent component, we'll mention with the help of Wn of nk. In which, what is Wn of nk indicates? It's nothing but your feedback, in which if you are taking the feedback concept, that point when you take a cross coupling of that numbers, when you want to write, when you combine these all into cross one, that first would be 0, then 1, then 2, then 3. Since it's 8 points, so 8, 8, 8 we have written. We are not writing for the first one, even components. Only for the odd components, if you want to design like this, we will mention. So what is the steps we have done? Once again we'll see. First we have taken 8 point. That 8 point, what is asked in the question? They asked to draw it by using 2 4 points. So that first 4 point, second 4 point. First 4 point we mentioned, it's what? What kind of component these are? Even points we have taken, even number of samples we have taken. This is what? Odd. So odd number of samples we have taken. So odd points we have taken. After that, even and odd. That both we have written by using the blocks. We are representing. We are not simplifying. Just a block diagram likewise, you remember. In this 4-point DFT, all are even components. Second, all are odd components. So that even components we are taking, right? This 4, since they asked the 4 points, so we have taken 4 points. We combine with the last 4 output. What is these all are values? These are called as what? These all are your output. So first, these all 4 we have mentioned. Then this we have mentioned. So in that, the first one, weighting sequence. What is the first weighting sequence? Xe of 0 and Xo of 0. That should be here. And in that we have mentioned weighting sequence. And weighting sequence always you have to mention, whenever you are taking weighting sequence, that is nothing but your Twiddle factor, that is this one. Instead of mentioning this whole exponent, we are representing in this way. That 8, 0, 0, 1, 2, 3. So we have taken this 4, 5, 6, 7, that is for even component. 0, 1, 2, 3 is for odd component. We drawn in this way. That is for 8 point. Likewise, if you want to design, we can design for 4 points also. So how do we do it? In that 4 point, we have designed in this way. If they ask to design by 2 points, then what we'll do? We'll make 4 2 points blocks. First 2 points, 2 points, 2 points, 2 points. First 2 points would be even, next 2 points would be odd. The same blocks we will design. So that's how your designing, just we have seen the designing of a butterfly diagram for a DFT. This is just representation of DFT. We did not proceed with our problems. So that we will see in the next class. For today's class, what you need to remember? You need to remember that this DFT is it requires a lot of steps to solve the problems, whereas in FFT it's simple. From the graph itself we can find out the value. In DFT the computation is what? N square in DFT, whereas in FFT what is it reduced to? N by 2 log 2 of n. So the complex addition and multiplication, that depends upon the logarithmic parameter in FFT. The next what we have discussed about the construction of an 8 point DFT from 4 point DFT. Thank you for today's class, and practice this thing. So in the next class we will see the problems of your FFT algorithm in decimation in time and decimation in frequency. Thank you.